Hello everyone. Welcome back to Dr. Lu's VCE Chemistry channel. Today, let's learn about the 2019 VCE Chemistry examination. We will focus on questions related to fuels and reaction heat. This section includes the type of fuels, enthalpy of reaction, and calorimeters. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The complete combustion produces carbon dioxide and water, so C and D are eliminated. Option B, oxygen is not balanced, so B is eliminated. Only option A produces carbon dioxide and is balanced. So, A is correct. An endothermic reaction is labeled positive. So, A is eliminated. The condensation of a gas to liquid is exothermic, so enthalpy change is negative, and B is correct. The enthalpy change is the difference between the energy of reactants and products, not the activation energy and energy of reactants or products. So, C and D are eliminated. First, calculate the calorimeter constant. Second, calculate the energy released by 4.20 grams of sucrose. Finally, calculate the energy released by 1 gram of sucrose. Fossil fuels are recognized as a significant contributor to the rise in carbon dioxide levels in the atmosphere. To reduce greenhouse gas emissions, biofuels substitute fossil fuels to provide energy. However, there are different opinions about the suitability of biofuels, such as biodiesel. These opinions are listed below. Discuss the carbon neutrality of biodiesel. Carbon dioxide is absorbed by plants used to produce biodiesel. So, more carbon neutral as biodiesel produces less new carbon dioxide than other fuels. However, biodiesel is not completely carbon neutral. When biodiesel is produced, petroleum diesel has to be used. Also, clearing land for crops by burning trees releases carbon dioxide and destroys habitat. Photosynthesis is reduced when land is cleared. Burning biomass directly emits a bit more carbon dioxide than fossil fuels for the same amount of generated energy. Against, some regions are not suitable for oil-producing crops. Uses crops/land that could be used for food/food production. The excess use of fertilizers can result in soil erosion and land pollution. Nitrous oxide release from fertilizers could have a greater 300 times more global warming effect than carbon dioxide. The use of water to produce more crops can put pressure on local water resources. Using biodiesel as a fuel for transport produces less toxic pollutants and greenhouse gases than petroleum. Diesel reduces dependence on foreign oil reserves as it is domestically produced. Can be used in any diesel engine with little or no modification to the engine or the fuel system. Higher flash point, which makes it less combustible and therefore safer to handle, store, and transport. The lubricating property of the biodiesel may lengthen the lifetime of engines. Against, higher viscosity/not suitable for use in low temperatures. Biodiesel fuel is more expensive than petroleum diesel fuel. Sustainability of using biodiesel as a fuel for plants can be produced/grown in a short period. It can be made from waste vegetable oils, animal fats, or restaurant grease. Releases fewer toxic chemicals if spilled or released to the environment. Many byproducts are biodegradable. Biodiesel produces less soot, particulate matter/carbon monoxide/unburned hydrocarbons/sulfur dioxide. Crops that produce oil can be grown in many places, can use second-generation technologies to convert materials such as crop residues into bioenergy and avoid competition for land. 2 marks were awarded for at least 2 valid points for, 2 valid points against, or 1 valid point for, and 1 valid point against carbon neutrality related to biodiesel. The same was awarded for sustainability related to biodiesel. Or 1 mark for at least 1 valid point, for or against, regarding sustainability related to biodiesel. 1 mark for at least 1 valid point, for or against, regarding carbon neutrality related to biodiesel. 1 mark for at least 1 valid point, for or against, the use of biodiesel as a fuel. 1 mark for a second valid point, for or against, is one of carbon neutrality, sustainability, and use as a fuel. 65% of students obtained 2 or more marks, although many did not fully explain why biofuels were carbon neutral or renewable. Some who tried to incorporate the media statements did so without really making headway in explanation. There was evidence that time pressure affected some students. Monounsaturated fatty acids are the main component of hazelnut oil. This oil is used to produce biodiesel. Compare biodiesel from hazelnut oil to petrodiesel in terms of chemical structure, energy content per kilogram, and flow through fuel lines. Acceptable points included. The energy content of biodiesel is slightly lower than petrodiesel. Biodiesel contains oxygen and, therefore, is already partially oxidized, whereas petrodiesel is mainly composed of hydrocarbons. More biodiesel is required to produce the same amount of energy, thus it is less efficient to use biodiesel / more biodiesel must be produced to replace less petrodiesel. In situations where storage of the fuel is limited, either smaller distances can be traveled, or more frequent refueling is required when using biodiesel. Cars require a larger fuel tank or closer refueling stops. Petrodiesel molecules have mostly saturated hydrocarbon chains, whereas biodiesel molecules made from oleic acid have a longer monounsaturated hydrocarbon chain. Biodiesel molecules are alkyl esters, whereas petrodiesel molecules are hydrocarbons. Ester groups / bonds increase the viscosity of biodiesel due to the stronger polar interactions between the molecules. Higher viscosity of biodiesel limits its use at low temperatures / more energy is required to pump the fuel. One mark was awarded for recognition that biodiesel has a lower energy content. 1 mark was awarded for explaining the difference in energy content. 1 mark was awarded for the impact of the lower energy content on the use of biodiesel as a fuel. 1 mark was awarded for the effect of the ester group on the interactions between the molecules. 1 mark was awarded for the effect of intermolecular forces on viscosity. This question was handled significantly less well than Part A. The main areas in which responses were less successful were an explanation of the energy content difference and the relationship between intermolecular attraction and viscosity / flow. In this section covering fuels and heat of combustion, 3 multiple-choice questions are awarded 3 marks, and 1 short answer question is awarded 9 marks. The overall score for this section is 12 points. With a total possible score of 120 points, the percentage for this section was 10.0% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.